Like sands through the hourglass, so are the days of our lives.
Hello everyone, welcome to Java Sessions. Now those exciting algorithms we've been talking about. By the way, before I get into this exciting thing, let me just say, if you're new here, please do subscribe, leave a like, leave a comment if you get confused about everything that I do in this video. So a two-dimensional array, ne? Today we're going to do two-dimensional array which deals with hourglasses sum. So what you're going to do is just compute the hourglass in a sum in a 6x6 two-dimensional array, and then we compute each and every sum of each and every existing hourglass in that two-dimensional array. By the way, and it is this thing, when I say hourglass, I mean like this shape. It's pretty much self-explanatory. They even explain it here: A, B, C, D, E, F. Like this is an hourglass. So the sum of this hourglass will be 1, 2, 3, 4, 5, 6, 7. That will be 7. So now we will have a 6x6 dimensional. Actually, here it is. Let me just show you, and I'll just let you wait in suspense. So we're going to have this two-dimensional array, which is a 6x6 dimensional array, and then we're going to add each and every sum of every existing hourglass here, and there are 16 hourglasses that exist. 16 hourglasses that exist in a 6x6 array. So we're going to have to compute 16 sums, and then within those 16 sums we have to look at which one is the highest, which one is the maximum sum. And then as you can see here, 28 is the maximum. You can pause the video and see through it. So I'm going to urge you right now to pause the video and then try to do the question on your own. Just try to do that. I'm pretty sure you'll enjoy it. And this is an explanation of how many hourglasses we have, which is blah 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 16 hourglasses, and then the maximum one here, it gave them 19. Awesome. Let's just get onto the video. I think I've been talking too much. You probably understand the question right now. So first of all, I'm just going to set up an environment. I'm going to create a two-dimensional array. I'm going to create an exactly copy of this two-dimensional array, so we can have somewhere to start. So creating that two-dimensional array is in answering the question, so I might just speed up the video when it comes to that. Peace out.
And that's for sure. Don't throw in the towel, don't give up now. Raise your chin up now. I said, don't throw in the towel, don't give up now. Raise your chin up now. Hey, that's what I told myself. 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 They throwing dirt on my name, making fun of my pain, trying to make me a lame. Look at me strange, I made some mistakes. I'm not a saint, I was on them things every day, trying to ease up the pain. Had to switch up the lane, I'm taking off like a plane. I can never be tamed. Yeah, you know what they say, no pain, no gain. I'm just trying to get paid, hustle hard every day. Don't throw in the towel, don't give up now. Raise your chin up now. I say.
Awesome. So we've managed to set up our two-dimensional array. That's brilliant. So actually what I planned to do here was to use scanner to input values. You know how I always like to give a user or myself an option to enter any value that I wish to enter, but then kind of thought about it. Here we're dealing with 6x6 matrices, so that means we're gonna have to insert like 36 items. Like you're gonna ask enter the first item, insert the second, till we reach the 36. Yeah, we couldn't do that. That's too much. That's too much work. So I decided to create a string array and then separate it using commas so that I can get columns using string tokenizer. String tokenizer will just get in each in any array, in any string that we find in this string array. We're gonna remove a comma and then get the value before that comma. So each value before and after a comma gets inputted into this array. So that's how I created a 2D array. And if I compare this, bam, exactly what you will find here. Where is it? Exactly what you'll find here, which is negative 9, 1, 1, 0, negative 9, and then blah 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 blah. So what is asked for us to do is not actually to display this thing. What is requested from us is to create an algorithm that will compute the maximum sum. So if you can look at here, first it computes negative 9 times 7, that gives you negative 63. Then it moves on and then says 0 times, that is actually not 0, I said negative 9 times 7 because everything here is negative 9. So and then after that it goes to 0 plus negative 9 plus negative 9 plus 1 plus 1 plus negative 9 plus negative 9, and that gives you negative 24. So it keeps on computing everything here in our hourglassly manner. I don't know, I just put this. I just get that one in hourglassly manner. So yeah, that's basically the whole idea here. So I'm gonna have to focus on these values here. The values 1 unit before the end and the values 1 unit after the beginning. These are the ones I'm gonna deal with, the middle values, because if I go here, the mathematics behind it will just confuse me. And there's this is software engineering. We always take the easier part. Let's move on. Okay. So first of all, let me scan through. Let me remove this. This was just to display. It has nothing to do with the solution. Let me display the solution here. Say system the print line. Say the hourglass sum. The maximum hourglass sum. Yeah. The maximum hours just is then our function gonna call it our plus sum, and if the parameter takes it to the array. Awesome. But we'll have to create that function first, and I'm pretty sure we'll figure that one out. Okay, so this will put out the maximum hourglass sum. Let's create that function. Oh, come on. Awesome. Okay, at first I had an idea that I'm going to use an array that has 16 values, and then that way will keep on showing each sum of each competition that we do, each hourglass competition that we do, and then that array will store the maximum value. But then I think it will be easier if I just get the maximum value from the get-go. Like immediately after I get the sum, then I compute, is this sum higher than the previous sum? If it's not, then I don't replace it. If it is higher than the previous sum, then I will place it. So I think that's what I'm going to do. So the one that will keep on storing temporary sum, let me call it temp sum. Okay, now we can jump into our 3 array. Say for each is equals to 0, is less than 6, because it's easier this way, and it also decreases the time complexity. Like if it was going to be if you're going to create another two-dimensional array, then it was going to compute like n squared plus n times, and then that's in the worst case, and that's just bad for them. You always look for the faster code, not the code that works. Always the faster code. But that's just my philosophy. I don't know about you. Awesome. Okay. And now how we're going to get the temp sum is simply by saying temp sum equals to array. We get the major array first. Oh, this is not the major array. Like I said, you have to start from one row after the first, and we ended one row before the end. So we started 1 and 5. So we're gonna say yeah, it should work. Okay, this is the middle one. Then let's go for let's go for the half wall before we go to the below wall. Now we look with respect to this middle one, what's the relationship between the first wall and the second wall, the one that we're dealing with, the second, I mean the middle one, the hourglass. Well, we can simply see that it is 1 unit above the middle wall. This one is 1 unit below the middle wall. So that means this whatever the index is here minus one, then you get to the top wall. This whatever this is plus one, and then you get to the bottom wall. And the columns also work the same way. So we're going to need to go to minus one, and then go to the column that is also at minus one. Oh my god. No, come on. This. Okay, minus two dot. And we're gonna need how many of this? 3, 3, 6. Awesome. And 1, 2, 3, 4, 5, 6. Okay, but obviously they are all not the same. This one is already computed. As for this one needs, and then as for this one, it should be plus, and as for this one, it should be plus. No need. Plus. No need for anything. Plus, let's look at that. Okay, okay, that's true. Awesome. We do every word beside the word that we are focusing on, which is the middle one. That's what we only do with when you go to that middle there. As for the others, you go into the top wall or the below wall. That's the whole point of an hourglass algorithm. And what the hell is going on now? What's this? Oh, I named this temp sum instead of temp sum. Awesome. And then now we ask if temp sum is greater than max sum, definitely max sum should be the temp sum. The new max sum should be the one that is greater than the old one. That's the logic behind it. So this is what I meant when I said I'm no longer using an array. At first I thought of making this temp sum an array and then keep on storing each and every sum, and then after that go through that array again and check if I find a value that is greater than 0, and then you could just do that here. This is that was just going to mess up my computation complexity. So let's I think I'm already done. Not mistaken. I think I'm already compare this. I should be done. Wait, where do I get 27 now? Yeah, something doesn't add up. J plus J minus 1, I minus 1 goes to J minus 1, and then goes to J, and then goes to J plus 1, and then I plus 1 goes to J minus 1, and then goes to J minus 1. Oh yeah. This is why I'm not getting 28. Perfection here. Let me see. Oh, it is 28. How awesome is that? So we got our maximum hourglass sum. Like I said, this wasn't even that complex. It was just a matter of 2 for loops. Now that I've come up to the solution, I kind of feel bad that I wasted your time. I thought this algorithm was going to be a big thing, honestly, but well, next time I'll think of something harder. I'll find something harder. So anyways, if you made it to the end, thank you for watching. Don't forget to subscribe, leave a like, and leave a comment if you're confused about anything that I did here. I'm out.